Welcome to McArdle Math Academy. In this video we will be looking at Bayes' theorem, and in particular we'll be doing an example that involves pulling balls from three different buckets. You may see this as the three-urn problem as well. So let's look at the following example involving three buckets, bucket 1, 2, and 3, and each bucket has a different number of red and blue balls inside of them. Now the experiment involves selecting a bucket, so we select a bucket, and then from that bucket we choose a ball and observe the color. Once we observe the color, we replace it in the bucket and then draw another ball from the same bucket and observe the color of that ball. Alright? Each bucket is equally likely to be selected, and in the end of the experiment we are told that both balls that were observed are red. So we're kind of fast forwarding to the future. We know that both balls are red, and now we can answer questions about what happened in the past using Bayes' theorem. Alright? The first question is, what's the probability that bucket 2 was chosen by the person performing the experiment? And the second is, what's the probability that bucket 3 was chosen? Now we can answer these questions using Bayes' theorem. I'm going to show you the technique to do so, and it involves first creating a tree diagram. Let's say Buzz Lightyear is the guy who's going to do the experiment, okay? So Buzz Lightyear, the first step is to choose either bucket 1, bucket 2, or bucket 3. As we construct this tree diagram, we want to include probabilities associated with taking each of the branches. We were told that the buckets were equally likely to be selected. That means that Buzz has a 1/3 chance of selecting B1, a 1/3 chance of selecting B2, and same 1/3 chance of selecting B3. Now let's go up to the top. Suppose that he chose B1. Well, he can now either choose a blue ball or a red ball from that bucket. If you look back at the statement of the problem, you'll see that he has a 2 out of 10 chance of getting a blue ball and an 8 out of 10 chance of getting a red ball. Now we can do the same thing with the tree diagram for if he selected B2 and B3. Notice that for bucket 3, all of the balls are red, so I haven't even included a blue branch, and the probability of getting red is actually just 1. Now, he replaces that ball into the bucket he took it from, and he draws another ball. So on the top choice here, if he had drawn a blue ball from bucket 1, he puts it back, and now he can draw a blue ball again, or a red ball again from bucket 1. And these probabilities are the same as they were before because of the replacement. So he has a 2 out of 10 chance of drawing a blue ball, and he has an 8 out of 10 chance of drawing a red ball for that specific option. If we hadn't replaced the blue ball, then the probability of making the second selection would be reduced. For example, the probability of selecting a second blue ball would be reduced to 1 out of 9 because there's only 9 balls total. The first blue ball wasn't put back, and so we only have 1 out of 9 blue balls left and 8 out of 9 red balls left. But since we replace it, we have those same probabilities here. Now I can fill out the tree diagram as I had for the first option for the rest of this tree, which I'll do now. It's important to note that the reason why this works is because once we choose bucket 1, all of the 2 selections of balls will come from bucket 1. So once you choose blue from bucket 1, you're now selecting from bucket 1 again. That's why these probabilities are all the same as they were in the branch prior to it. Alright, so we're going to use this tree diagram to answer the question and apply Bayes' theorem. Alright, now, in order to answer the question that's set forth, we have to remind ourselves that the problem tells us what the outcome of the experiment is. So they already say, well, Buzz is going to observe 2 red balls. So let's highlight all of the branches that encompass this situation. So he could have gone up branch 1, picked red, and then picked another red. He could have gone branch 2 to red, or branch 3 and gotten both reds. Those are the only 3 possible things that Buzz could have done if he was going to observe 2 reds after the experiment is over. So what we're asked is the probability that bucket 2 was the bucket that was originally chosen. And so we know the future, we know the outcome, and we're trying to find probability of something that happened in the past. And that's where Bayes' theorem comes into play. To find this probability, Bayes' theorem says that we have to take a ratio of 2 things. Alright, I'm going to write what these 2 things are and then explain it. So the ratio is the following. In the denominator, we have to take the sum of the probabilities of all branches that include 2 R's. So these are all the possibilities that Buzz could have followed in order to get 2 reds. And when you say probabilities of the branches, you're just going to multiply across all these probabilities. So for this first branch, it'd be 1/3 times 8/10 times 8/10. Then you'll add that to the probability of this branch, which is 1/3 times 7/10 times 7/10. And the same for the third branch. In the numerator, you put the actual probability that you're trying to find. So we want to make sure that bucket 2 is the one that was chosen. So in addition to the two r's, we want just the branch that goes through bucket 2. So in the numerator, you only include the probability of this branch. So only this product. And I'm going to add all these things. I'm going to put all these things down right now. So you can see here that the black that I've drawn here, that's corresponding to the middle branch, which is the branch we're actually looking to find the probability of. And then I have the red branch going up, that's down here, and I have the blue branch, which is the one that comes down. And there's Bayes' theorem, so if I do all this out, we'll get a probability. So let me pause this for a second. And so we get an answer of 0.23, and that's our probability that Buzz chose bucket 2, given that 2 red balls were chosen in the end. And the same strategy can be applied for part B. So again, you highlight we're under the same assumption that he chose 2 red balls, so we highlight all of those branches. So again, you could have gone to B1, you could have gone to B2, or you could have gone to B3 to get your 2 reds. And then you take a ratio of the sum of all of those things in the denominator, and then the branch that you're actually looking for, which in this case would be branch 3, with the bucket 3 there in the numerator. And when you do that out, you'll get a probability of 0.469. And it makes sense that it's more likely for Buzz to have chosen bucket 3 if he got 2 reds, because bucket 3 is almost going to guarantee you 2 reds. All right? So it's definitely logical that it's more likely for him to have chosen bucket 3. All right, I hope this helps, guys. I'll see you next time.